Hey guys, and welcome to this episode of GoBuilda TV. This is an especially exciting one for me because it is the 30th episode of our show. So we've been running for over a year now. I am super excited that you guys have kept tuning in. For those of you who have been here since the beginning, an especially large thank you to you guys. This episode in particular, we're going to be talking about belts, pulleys, and chain. And specifically, we're going to be primarily talking about timing belts. We're going to talk about ways you can use different belts, when you should use one kind of belt versus another, and when you should use chain versus when you should use belt. I know that this is an especially talked about kind of debate in a lot of FTC circles. Hey, should I use belt or chain? And I think there are a lot of different opinions out there. So if you have an opinion, a leaning one way or the other, let us know. And I'll definitely kind of be working through the chat and hopefully be able to read some of your comments there. To start off, we'll talk about what we're going to be talking about here, which is specifically, we're going to be primarily highlighting 5mm HTD. This is a larger pitch than a lot of FTC applications require. And the big reason we went with that is because we can make it a little narrower than a smaller pitch and handle that same amount of torque. So within the GoBuilda line, we have a couple of different sizes of the profile of HTD belt. We have a 5mm pitch and a 3mm pitch. That 3mm pitch is 15mm wide. So it's a wider profile, and the big advantage with the finer pitch is that you can run a more aggressive ratio, so more of a reduction in the same space. We've got definitely a lot of discussion in the chat about which one people prefer between belts and chains. So like I mentioned, if you have an opinion, let us know. So we're going to talk a little bit more about 3mm versus 5mm pitch belts. We're also going to be talking about chain. Now we're going to focus on 8mm pitch chain, metric, that's 05B. And that's because that is the chain size we use in GoBuilda. It makes the most sense and works out the best with the pattern. And we're also going to be talking about, very briefly, some round belt and other kinds of belts you may want to use in GoBuilda. But first, we're going to talk about a new product, sneak peek, that we haven't launched on the site yet, and one that I've been excited about for a really long time, and that's a couple of new sizes of gecko wheel. This is the first option we're going to be looking at. This is a product that's going to go live sometime next week. Kind of hard to see because it's nice and black, but it's a 48mm gecko wheel. It's got a very similar design to the other two sizes, the 72mm and the 96mm, but this one is a little different in that it is press-on to 8mm Rex shaft. So it will slip on and have kind of a nicer, almost press fit onto that shaft and stay where it's at a little bit easier. This will be especially nice for assembly. Before you quite have that constrained, you can just slide that on there and have it stay relatively in place. It is 16mm wide, so thinner than the 24mm of a standard gecko wheel. A standard being 72mm or 96mm, and I'm really excited to see what you guys do with these, especially in roller intakes where you have a few of these lined up in a row. Like I said, these will go live probably sometime this week, so we are super excited to get these out to you. The next intake wheel that we're going to be talking about is we call it the boot wheel. I'm excited about this one. This is kind of one of those wheels that I had a lot of fun with. I can kind of give you a lighter background to look at it against. It is the same press fit over 8mm Rex bore, but it is 8mm wide, so it's narrower. And it's got, both of these have a hard plastic core that silicone 30A rubber is bonded to. So this one's cool because you can run it in either direction and have different intake characteristics. So you may run it forward with the boots kind of grabbing something and pulling it in a little bit more aggressively, or you may run it backwards where the kind of heel of the boot is grabbing whatever element that is and pulling it toward the robot. So I love these things. I think they're going to be really fun for use in FTC, and I think these are kind of interesting, especially when you compare them to something like a surgical tubing intake. While they are potentially a lot less flexible, they are, and by flexible I mean flexible in how you create them in your design, not by, actual physical characteristics. They are, well, a little bit more limited in what you can do, but they are very easy. They'll just go on a shaft and you're pretty much done. Now these two wheels both have a hard plastic core like I mentioned earlier. That is something that we were able to get and sell separately as a spacer. So we have an 8mm Rex ID, 12mm Rex OD spacer now in 8mm length and 16mm length. These are especially nice because they are very affordable for your intakes where you may have a bunch of roller wheels. These are really nice to fill up the space between your different intake wheels for a very reasonable price. These are going to be really sweet. They'll be sold in 12 packs, so you'll get a handful of spacers to use on all of your robotics projects. I think these are going to be sweet. If I was a team, I would have just a stock of these guys because they're going to be really useful and really easy to have a bunch on. Kick the game elements, that's about it. Are there going to be bigger sizes for the boot wheels? That's definitely something that we've given some thoughts to. If they are in the works, they're too far out to talk about, unfortunately. But those would be really, really cool. Kind of to be a little bit more comparable to that surgical tubing intake where you may have a much larger game element. These are both very small, really, really useful if you have an otherwise sprung intake or otherwise compliant intake and you're not relying on just the thing that interacts with the elements to make up the difference in size between the blocks and the balls. I'm also excited about especially these boot wheels for not FTC applications where you may have a small scale robot that needs to pick up pencils or ping pong balls, where this feels very, very in scale. And these, especially those little kick-ups, could potentially let you grab very small cylindrical objects a little bit easier. So these, like I mentioned, will be up fairly soon. I'm excited about them, very excited to see what you guys do with them. I have Sky Blue Zombies says, hi Ethan. Hello, how's it going? Let's get right into the headline topic for the show. The first build I have for you today is a 5mm HTD belt. This is a center distance that, let's see here, 2, 3. The thing to talk about here is that with a 5mm pitch belt, you will not always have a tooth count that's possible to create in the belt that lines up on the GoBuild pattern. That's because each tooth repeats every 5mm and the pattern of GoBuild repeats every 24mm. And 24 repetitions of 24 isn't evenly divisible by 5 except every 5 holes. So a 5-hole channel like we show right here works just fine as a direct center to center. But anything besides 5, 10, 15, 20 will not work out. And the big thing there is that center distance needs to be evenly divisible by 5mm, like I mentioned. So 120 millimeters, 240 millimeters, all lengths of GoBuild a channel that work out with 5mm pitch belt. This is the big advantage of 3mm pitch belt. Because 24 millimeters is evenly divisible by 3, any number of the GoBuild pattern you can use with a 3mm pitch belt and have it work out. Now, this is a downside of 5mm pitch, but is a big reason that we have tensioners a lot in GoBuild. These are our small acetal tensioners. They're designed to go on a standoff, and they're very easily to mount on a piece of channel and add some additional tension. We also have the arc slot tensioner that is great in combination with this to really precisely control the amount of tension that you want on your belt. With belts, you may want more or less tension depending on what your goals are. You may need to handle a ton of torque sometimes, or want something that may not need as much ability to handle torque, but needs to run very, very smooth, where you may want less tension on that belt in the same circumstance. That's where designing around having a tensioner and GoBuild a channel make a lot of sense, and is a big reason that we decided to go with this as our primary belt system for this scale robots. These are, like I mentioned, 9mm wide, so they are crazy, crazy powerful. There are applications where you can break these in FTC, especially really long arms that end up swinging around and hitting things, but it's very uncommon. And a great thing about belts is that they about stay the same. Let's give a quick overview of chain before we get into the really direct comparisons between the two. The chain we use in GoBuilda is always 8mm pitch. This is because, like I mentioned earlier, that 24mm pattern is always divisible by 8mm. So no matter how many, sorry, that chat made me laugh. No matter how many repetitions of the GoBuilda pattern you have, it'll always line up with an even center distance. That is something that's a big advantage to chain. The primary advantage to chain, in my opinion, is the ability for you to change its length after you buy it. With a closed loop belt like this, it's this long. This one, for example, is 650mm long. It'll always be this length, and aside from a tensioner, which you may be able to adjust the center distance by, say, 5 to 10mm, that's the length that it is. Chain is a completely different story. Once you have a link of chain, you can break it and put it back together, and break it and put it back together, and keep reusing it in every application you can think of. Everywhere you need chain, any length of chain, as long as you have physically enough, works for you. That's a big reason I'm a fan of our chain tool, because you can break 2 lengths of chain, put them together, and have 1 long length of chain just like that. So that is definitely a big advantage to chain over belts. You can have about whatever length, and that same chain can be used over and over again. Now, that is something that can be really nice, but it is unfortunate that chain of these two is the one that can stretch. Because this is a mechanical component, each one of these joints can develop a little bit of play throughout the course of a robot's lifetime, and that means the chain can have a little bit more center distance added between each of these links as time goes on. So that is something that you have to keep in mind with chain. You may need to add a tensioner if you have a very high load application and you are working with that chain for a very long time. In a lot of industrial applications like bikes mentioned in the chat, they have dynamic tensioners that are based on spring tension or just the ability for the chain to move. So a lot of applications where you need that center distance and the amount of tension to be very precise, you want a dynamic tensioner, an active tensioner, compared to a static tensioner like we normally will use on a belt. By contrast, belts are generally have fiberglass cords running through the back of the belt. This makes them very, very tough to stretch, especially past the very first break-in of a belt. You may have a little bit of stretch, but after that they are very, very solid and tend to be about the same diameter throughout their lifetime. So while you definitely have a longer, you have more adjustability and more ability to change the chain you have, it may not last as long without stretching. Stretching may not be a downside in some applications where it's okay if it develops a little bit more backlash into the system. So what I'm going to do today is we're going to put together these 2 lengths of chain. These were both loops. While I've been talking, I broke both of those loops open, and we're going to put them back together. Now, primarily we've been talking about steel chain today, which I think is the one that many FTC teams end up using, but plastic chain is a really cool option as well. Plastic chain is, of course, easier to work with. You don't need a tool specifically to break it and put it back together. But depending on the amount of time it may take to assemble that chain, I think you could potentially create a mechanism with steel chain faster. So I now have a long length of chain. We are going to change this assembly over here out for belts, and we're going to put chain and sprockets on it. As long as I remember to grab the right length of screw, that should be no problem. Let's see here. I want to make sure I haven't missed anything over in the YouTube chat. And while I'm thinking about it, we should go ahead and start our giveaway. That's, of course, something that I should have set up before the stream, but you live and you learn. Or in this case specifically, forgetting to set up giveaways is not something that I've learned yet. So we'll go ahead and get that set up while we are thinking about it. If you have any opinions or questions about belts and chains, or anything GoBuilda, make sure to drop them in the chat on YouTube or Twitch. You can ping us at GoBuilda TV just to make sure that we see it. All right, here. So our giveaway today is going to be a hoodie. I was the person who chose the hoodies and shirts that we end up using here at GoBuilda. We print them on a really nice hoodie. That's why they're kind of expensive. It's a hoodie that I printed my team hoodies on back when I was in FTC. I love the Independent Trading Co. EFX 4000. It's a great base hoodie. They're super comfy, and the one I've had longest I've had for like 5 years now. And they last forever. Not quite as comfy as the day I got it, but I think they are really nice and high quality, and same with the shirts. I have some of these shirts that we print GoBuilda shirts on that are just plain that I wear all the time. I'm basically wearing a version of this Next Level 6010 every day. So I love them. I'm really glad that I got to choose them. Of course I would wear them every day because I got to choose the one that I really liked. Okay, we're going to do hoodie as the giveaway. We're going to do warm as the giveaway. That's a fun one. And I'll go ahead and set that all up in the chat. Hey, GoBuilda. If you do end up winning, make sure you send us an email over to marketing@gobuilda.com and make sure to include your size for hoodies. I would say these, if they were going to run small or large, I'd say they might run a little small. I would probably size up. That's also kind of nice. Okay, and that is running. I figured that would be a fun giveaway. Since we're kind of getting into the fall season, it gets to be a little bit nice to have a hoodie to walk around with. That should be running, so make sure to type that in the chat. Make sure you're following in order to win. And if you're watching on YouTube, unfortunately, you'll have to make your way over to Twitch to enter this giveaway. Let's see here. Yeah, let's jump right back into it now that we've talked about team shirts and hoodies and all that stuff for a few minutes. We'll jump right back into it. This is the length of chain that I just broke, but put back together as a solid length. Now let's go ahead and move our belt system over to chain real quick, and we'll keep the center distance the same. Now, I said earlier that 8mm pitch chain will always work on GoBuilda channel. That's true, and especially true of plastic chain, but with steel chain, that requires a bit of an asterisk. Steel chain has two kinds of links. I'll pick one up, kind of pause what I'm doing so I can talk about it. It has what I like to call an inside and an outside link. One of them is it has a narrower dimension so that it will fit between two larger outside links and allow that chain to run. Each of these links is 8mm pitch. So you have an 8mm pitch inner link and an 8mm pitch outer link. But you've got to always have one of each, which means by default with normal chain, there are lengths in between two holes on GoBuilda with a 1-to-1 sprocket combination that do not work out with just chain. That's because effectively this is kind of a 16mm pitch when you're talking about the center distance that you have available for the chain. That's where add and connect links come in handy. These are half links, is the other common term for them, and they are an 8mm pitch link that is an outside link on one end and an inside link on the other end. And those are super handy. So if you're planning on working with steel chain, I would say make sure you pick up a few add and connect links just because they are very handy for those holes that are evenly divisible by 8 but are not evenly divisible by 16. Is there a way to calculate perfect center to center for chain like you can for belts? Yes, and it's actually the same exact process between both things. You have the amount of pitch, and you have millimeters, and you have number of teeth on the sprocket. The easiest way to do it kind of on the fly is a 1-to-1 ratio. 1-to-1 is very simple, and you can do belts or chain this way. And the way to do that is to take the center distance between both of your sprockets, pulleys, whatever, and multiply that by 2. That's because the belt has to travel the length of that center distance twice. It has to go here to here on top and then here to here on the bottom. You then divide that by your pitch. That gets you, so for a 5 mil belt, that's 5 millimeters, 3 mil, that's 3 millimeters, and for chain, that's 8 millimeters. You then add the total number of teeth on one sprocket or pulley. So you could, in theory, do half and half, but that would require you to do the other parts of the math correctly in order to account for the change in ratio. But it's a bit of a tangent. So you have the center distance times 2 divided by your pitch, and then you add the total number of teeth on one sprocket or pulley. So a good example we can run through is 120 millimeters times 2, 240 millimeters, divided by 5, which is too much for me, unfortunately, 48. So you have 48 teeth right there. Say you're using a 24-tooth pulley. You can add 24 to that, and you get 72. Pretty sure, right? Yeah, 72. That means you have a 72-tooth belt that is required for that center distance. You can then multiply that back out by your pitch if you want the number of millimeters. 362 millimeter belt, which is exactly what we had here, because that's the exact same setup we had. Now, if you were to choose a different length that doesn't work out as an exact center distance in GoBuilda, say you choose 144 millimeters, you're going to end up with a non-complete number at the end. Let's run through that real quick. So we'll say you have 144 millimeter center distance, multiply that by 2 to 288. We'll divide that by 5 millimeters, and you get 57.6 teeth. You can add 24 to that, and overall you need an 81.6 tooth belt to make that center distance work out. Now, that's not possible. You can't have half a tooth or 0.6 of a tooth in a belt system. So you've got to take up that extra distance somehow. You would take it up with a tensioner. So with that number, you'd get an 87 tooth belt. So that would be a 410 millimeter belt. And you would add a tensioner in there to soak up that extra bit of distance in the system. So chain is the exact same way. Like I mentioned, that really only works for 1-to-1 ratios. That's because that math is very simple, and as soon as you add basically, the Pythagorean theorem to figure out the length of each line in your system, it gets more complicated. You also have to figure out, say, how much wrap does this sprocket over here have compared to this sprocket over here. You can totally do that. I just don't feel like I can explain it in a live show without the use of graphics. There are thankfully a lot of really handy belt and chain calculators out there. We have one on the GoBuilda website for belt. We have that for 5 and 3 millimeter HTD, and that covers the sizes of pulleys that we offer. But SDP-SI, Stock Drive Products, Precision Instruments, I think, SDP-SI has a great belt calculator that can have any size of pulley, any size of belt. It's sized for MXL to M8 or 8 millimeter pitch belt. So those are, that's where I go if I'm trying to do a more complete belt calculation, and I don't feel like sitting down and figuring it all out by hand with those equations. That's a great resource to have under your belt as an FTC team. Okay, here looks like we have one screw that's just a little too short. Not sure why I did that, but that's okay. So we'll go ahead and bolt these sonic hubs, bolt these sprockets to these sonic hubs. So we'll have a chain system, and I'll show you guys how I break chain to be the correct length for a specific project. I'll grab another screw for that in just a second, so that way we get 4. Otherwise, that would be really sad. And then we'll do 4 on the second sprocket. These are a 14-tooth hub mount sprocket. These are probably, I don't know if I'd say the most used, but they probably are the most used GoBuilda sprocket. They fit in channel really nicely. They're hub mounts, so you can use a sonic or a hyper hub, which is just such a nice application when you're comparing it to set screws. Set screws are totally fine, but sonic hubs are just so hard to beat. Let's see, Rest Pieces says, I don't know hardware stuff, so this all sounds like French to me. Well, hopefully this show can kind of get you started on chain and belt. So the first thing we're going to do is remember to grab that last screw I talked about getting earlier. I'm going to steal it off this build over here. My fun swerve drive that I haven't got working yet. There we go, we'll add the last screw. Doesn't really matter here, but you know, it is nicer. And this is a good opportunity to talk about plastic chain. Now, plastic chain does not suffer from the inconsistency in center distance from that steel chain does. Each one of these links can connect to the very next link without a specific inside or outside link configuration. This is basically like all add and connect links in steel chain. And that is very handy because it means it's always super easy to make sure your center distances line up. So what I will do is kind of start running these on the sprockets. And I'm going to end up with one of these ends of chain wrapped just over the very top of this sprocket. I'll then take this other end and drape it over my center distance, find the link that I want to break, which is right here, and I'm going to break that chain with my fingernail. This is basically the same process you're going to use when working with steel chain, and we'll do steel chain also. But I'll show it in plastic chain just to kind of give you a sense of how difficult one may be to use over the other. There we go. How hard is it to take apart / connect plastic chain? There is a trick to it, especially when you get a bag of individual links and you've got to put 50 to 200 together. It's really not too bad once you get the hang of it. For me, I always struggle a little bit more with getting them broken. But you can generally get your fingernail underneath one of the ears of the next link and pop it out of the hole and then pop that chain apart. I'd also like to mention that this chain has been used and abused a lot, especially our plastic chain here in GoBuild. It gets a lot of use. So if it may seem a little bit, I think that this chain system may seem a little more stretched out than a new one you have. If you haven't seen it yet, we have a video where Jason here hangs off of a forklift on plastic chain, kind of show you how strong it is. So we definitely still have some chain left over from that experience, and this may be it. In retrospect, I probably should have pulled all new chains so you can see that, but hindsight's 20/20. What kind of plastic is it? Do you think it's feasible to 3D print plastic chain? This is acetal. It's also known under the brand name of Delrin. That's a DuPont brand. You can also call it POM. I can't remember what POM stands for, but that's fine. I don't think it's feasible to 3D print this. I love 3D printing stuff. It's sweet, but with this, a lot of the walls on plastic chain are very thin, and this really takes advantage of acetal / POM being very, very low friction, especially against more acetal. It'd be interesting to see some 3D printed acetal, how it'd hold up, because that is something that's possible, but it's a very difficult material to 3D print. So here is the setup we have with plastic chain. As you can see, this is definitely a little bit, it's had some life to it. It's a little bit stretched out, and this is what we were talking about with steel chain, but to a much lesser extent. This is where I would grab one of these little tensioners. These are also acetal, which means they have a super nice low coefficient of friction compared to the plastic chain. You can add that to a standoff on this channel and really precisely create the amount of tension that you want. Higher tension generally means it's going to be a little bit harder to rotate. You may have a little bit more parasitic draw from that power transmission device, where a more of a slip fit means you could have a lower amount of current required to drive that mechanism. As you can see, you can break plastic chain while it's on a mechanism. You may have noticed earlier, took one of these sprockets off to give myself enough play to assemble this plastic chain, put it over both sprockets, and then move the sprockets back into the channel. That is, in my opinion, that's the way I do it most of the time because it's easier. So we're actually going to go through that same process to show you how much more difficult it may be to create that setup with steel chain. So we're going to do the exact same thing. We're going to roll the chain around both sprockets and then go to the link that lines up with the link on the next sprocket. And we'll see here that 5 holes would make 120 millimeters is evenly divisible by 16. So that works just fine. We've got a inside link on this chain and an outside link on this length. So we're going to find that specific link. I'm going to grab it. Chain kind of folds in half, so I use that fold to mark where I need to break it. We'll grab my handy chain tool. Forget which link I was needed to break. Of course, that's the critical step. You've got to do this at least twice, I think. So that's right there. We'll line that up with the breaker pin and go ahead and break this. Now, doing a more close-up video on how to use this, we do have a video on it. It was, I think, the very first video I did here at GoBuilda, so excuse it if I hopefully have gotten a little bit better at this whole video live stream thing. But that goes into a little more detail on how to break and reassemble chain. I have seen some 3D printed chain mail. That's cool. I've always felt like that's pretty neat. I definitely wouldn't want to go into battle with some 3D printed chain mail, but I've seen it. It looks very cool. The big thing there is you can get a larger wall thickness on everything, and you're not requiring that to transfer torque. For a prototype intake, it might be okay, but I personally probably would just spend a little extra money and get some plastic chain. It's pretty inexpensive. I know that it's, you know, of course I'd tell you that, but that's kind of my personal opinion on it. Okay, boom. Now we've got a solid length of chain. That should be the correct length to go across both these sprockets. I'll do the same thing, or I loosen the pinch bolts on the sonic hub. Slide the sonic hub out on the shaft. We'll move the steel chain out of the way. Out on the shaft, slide the bearings out. So that way the bearings are not in the 14 millimeter hole, which gives you a lot more play in the center distance. That gives you the ability to move those sprockets close enough together to slip this chain over the sprocket. If you've ever had a chain fall off your belt, this is basic, not a chain fall off your belt, a chain fall off your bike. That's basically what you would be doing there. And then you kind of stretch it back out, put those bearings back in the holes, and then we will tighten up the pinch bolts on these sonic hub. Does Tetrix 25 chain work with GoBuilda/Acto sprockets? It would work with Acto sprockets, given they're both number 25 chain, but it would not work with GoBuilda. GoBuilda is all 05B, excuse me, 8 millimeter pitch chain. I think that I might have some 25 pitch chain hanging around here. To clarify, I do not. I thought I did. But 25 pitch chain is significantly smaller. To put that in metric, 0.25 inches is 6.35 millimeters. So it's a pretty significantly larger pitch, which means each link can be significantly larger. I think that 8 mil pitch is the perfect scale for FTC. I think it's even could be a really neat scale for FRC, where you may be a little too big, you break 25 chain, but 35 chain might be just a little too big for you. So we have our steel chain put together. I think that honestly took a comparable amount of time to the plastic chain. I do think that if you're trying to break it and put it back together very frequently, you may spend more time with steel chain than plastic chain, but especially once you spend the time to assemble it, I think you can get faster with steel chain. The thing about steel chain in that case is that it has a bit of a limited lifetime on how many times you can break it and put it back together. That's of course not great for each of those links, and while this is absolutely the strongest way to just break a link and put it back together compared to a master link, that's way stronger. It can sometimes make that specific joint that you broke in the chain have a little bit more stick. So it may not run quite as smoothly. I don't think you're ever going to notice it, but you don't want to be breaking every single link in a steel chain. It's very reusable and you can use it a ton of times, but there's going to be a practical limit there, where a plastic chain doesn't matter. You can break it as many times as you want. It'll always flex back into shape with it being acetal. Now, let's talk about how the cost compares between these three options. Talking about plastic chain, steel chain, and belts. Now, if you're just doing one run of a system, you want to go between these two center distances and that's it, belts are going to be your cheapest option. You're going to have a pretty low investment. You might spend maybe $5 on a really, really large belt, and you're going to buy those 2 pulleys, which are going to be about the same cost as 2 sprockets, whether those are hub mount or pinion pulleys or sprockets. That's where you're going to be your cheapest option, and you're not going to have any excess materials. It's going to work out. Your center distance is going to be either perfect, or you'll throw a tensioner in there, and that's where you get a lot of advantages in those very specific applications. That's why I think belts make sweet options for drivetrains, because you say, hey, look, this is how I'm going to build my drivetrain for this season. I might change it later on, but I can go grab another belt, and it's going to stay the same all year, and I'm not really going to have to worry about it. It's not going to stretch and change my center distance and maybe affect my autonomous. It's going to be the same. It's also probably going to be quieter, which on a drivetrain sounds cool. It may not have any practical benefit. You may even like the sound of chain better, making a little bit more noise, making it sound a little more menacing. But belts are going to be quieter if that's what you prefer. And if you know your center distance, if you know your application, and you know that's not going to change, they are awesome and going to be your cheaper option. Now, in the land of sprockets and chain, where you really see cost savings is when you have multiple use cases in prototyping that you want to do over and over again and run through the season. That's where chain can be amazing, because I can grab a meter of steel chain and use that over and over and over in different center distance applications with different sprockets and never have to worry about, hey, is this going to work out? Do I have to change my sprocket sizes or my pulley sizes to make this specific length of belt that I have on hand work out? You can make it work with whatever application you have, as long as you physically have enough chain. And that's going to be true of plastic or steel chain. Now, steel chain is something that we can just source, so it's going to be cheaper than a custom plastic chain to us. You can buy steel chain for cheaper than you can buy plastic chain. The thing that makes some applications of steel chain more expensive is the tool. You need to have a tool to work with this chain, and 1 meter of steel chain plus a tool is more expensive than 1 meter of plastic chain. If you're running through a lot of chain, if you really need a ton of applications, steel chain and a tool can be cheaper. And this can last you years and years, where you can grab another meter of chain next season and another meter of chain the next season, and keep reusing this tool. That's where that can be cheaper. I'd say if you are a lower budget team who may not have access to funds next year to buy a ton of robot parts, I would go steel chain. It's going to be the best long-term investment for you, as long as you keep this guy and you keep it in pretty good condition. Don't lose it. It actually has the pattern, so you can build it to your robot if you want. That is going to be the best way to keep your costs down season after season. If you are a team who just loves performance, if you really want to get that specific center distance that you need, grab belts. If that is 3mm belts, because you need a really aggressive ratio for that arm, you have a small pinion, you have a big pulley, that's where 3mm pitch grate belt is amazing. Or if you have a drivetrain, you know your center distance is going to be the same, grab a belt, grab a pulley, and you're off to the races. If you are especially a team with, I think, younger members, plastic chain's amazing. It gives you a ton of options for very quickly breaking and reassembling chain, and makes it very easy to work with and very user-friendly. If you've worked with Lego chain, it's pretty similar, except being a lot heavier duty. I think that those are both they're all 3 very strong options, and if you count 3mm belt, we have 4 options there for you. And I hope that that kind of sheds some light on when you should use one versus another. They think they're all really cool. It just depends on your specific application. As much as I would love to come in here and say, hey, look, I always use belts, I don't think that we reasonably can. Now, I think I would use belt most of the time. I think it's awesome. It makes a whole lot of sense. And from my use of it in FTC, it is a little bit more use and forget. It's a little easier to tension, especially than steel chain, and it's really cool. Timing belts are used all over in automotive, so are chain, but they are really neat. What do you think about prototyping with chain and then switching to belts later? that's a great option. I think that plastic chain's great for that. It's a little bit faster, and multiple people can be working on the same prototype at the same time. My friend over here might be breaking some chain real quick, so may this guy over here. We can all work on some plastic chain together without having to potentially need the chain tool all at the same time. So plastic chain, I think, is a little easier to work with, maybe isn't quite as fast as steel chain can be. So prototype in plastic chain, grab the belt and pulley that's specific to your application. Once you know that application is set in stone, that's a great option, especially if you know you're planning on doing some intake rebuilds after your prototyping season and other things like that. That's what we do, and that's pretty nice, says Star Gamer. I think it's a very sweet option, and you actually will probably see us doing that. We did that a little bit on our robot in 3 days, where you prototype with chain and then run in and swap out for belts once you know that's set in stone. It looks like we're about pretty close. We've got, looks like, a lot of our viewers who have said the keyword in the chat to be entered to win a hoodie. If you have not yet, make sure you get that in. I'm going to give you just another minute here to put that keyword in the chat. Make sure you're following and get entered to win. That should be about it. How do chain versus belts taste? I would really not recommend tasting any of them, but if you made me, I probably would taste the belts before the steel chain, at least. I guess they're all better than packing peanuts. The thing that I didn't talk about a whole lot is ratios. Really, we talked primarily about one-to-one power transmission, which within FTC is a very common thing. When you're going to create a ratio, you have a lot of options with each of these platforms, but I think the two that are the most flexible are 3mm pitch belt and chain. In both those cases, you can make very small diameter sprockets or pulleys and very large diameter sprockets and pulleys. So you can have a tiny sprocket and a huge one to create a very compact, very large ratio between two shafts. Same with 3mm pitch belts. The minimum acceptable bend radius on a 3mm belt is smaller than a 5mm belt. There's less material, and you can handle less torque, but you can create some crazy high reductions within one stage of belt. Let's see here. I think that's about most of our people. We got a couple more entries into the chat, into our giveaway. So we'll go ahead and close our entries and pick our winner. It looks like Christomatic is going to be our winner for this hoodie. Congrats. Make sure you get us your shipping info, your team number, and your hoodie size. Like I said, I probably would size up. It's up to you. I think that is super exciting. So we'll be excited to get you out a Go Build a hoodie, and you can see if they're as nice as I think they are for yourself. With that, I think we did a pretty cool overview of belts, chains, pulleys, sprockets, and more. If you have any questions about these or any other topics, make sure to shoot us an email over to tech@gobuilda.com, or you can find me on Discord, Reddit, and over here on Twitch, and I'd be happy to answer your questions. With that, thanks so much.